Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our course. This is Feature Analysis and Data Science with Stocks for Beginners. In this lecture, we're going to do a preview of the project that you will build in this course. So starting off, you're going to learn how you can load in a data set. We're going to be using Tesla stock fetched from Yahoo Finance for this project. Then we're going to perform our feature analysis and data analysis and visualization with that data. Feature analysis and being able to understand what's going on in your data, what kind of data you have to work with, is a key step of any kind of data science or machine learning project. It's a really important step of the workflow because if you don't know how to load data, how to analyze it, visualize it, make some sense out of it, how to clean it as well and prepare it for machine learning, well then you can't actually do any kind of project. So it's a very important step to any kind of project working with data like machine learning. So we're going to load in our data, then we're going to start performing exploratory data analysis on that data. So we're going to learn how we can actually analyze the data and find out what's going on there. Then we are going to move on to visualizing our data. So this is going to help us with our analysis because we're going to be able to create different plots. For example, we'll have these bar charts as well as histograms, line charts, these density charts. We're going to learn how to make a whole bunch of visualizations to help us understand the data. We're going to use different libraries that are very commonly used, including Matplotlib's PyPlot, as well as Seaborn and Bokeh, and as well Matplotlib 3D. We're also going to be able to find stuff like the counts and get different distributions of the data, including getting a histogram comparing all of the features and their correlations. As well, we're going to be able to rank feature importance. So we're going to be able to choose an X and a Y, the X being a collection of features about the stock, and the Y being one of the prices of the stock. For example, it could be the closing price of the stock, could also be the returns that you get. And then we're going to use this ranking system known as Shapiro ranking to find which of the features has the most influence on something like a stock's closing price. So we're going to find feature importance, which is quite valuable for any kind of machine learning project to know which features are actually relevant and which features should you discard. As well, we're going to perform another type of ranking known as this two-dimensional ranking covariance. So more on that coming up. And that is going to be the project. So very fun project, a lot to learn in this course. You're going to get a thorough introduction to data science feature analysis. All that you'll need to take this course is experience with Python. So if you have no experience, we will include for you a section on how to program in Python. So feel free to watch that prerequisite section if you have no previous experience. If you do have Python programming experience, then you can skip the Python programming section and just jump straight into the feature analysis and data science section. As well, we'll be coding in Google Colab, which is a free online code editor, so you won't have to download or install anything for this course. Very fun course. I'm excited to get started with you, so join me coming up in our next section. Hello everyone, and welcome back to our course. In this lecture, we're going to start our project of feature analysis and data science with stocks. First steps first, we're going to load in our data set. So join me at Google Colab by visiting colab.research.google.com. This is an online code editor that we can use to code in Python. And we're going to get started. First steps first, we're going to install and import Yahoo Finance. So call pip install y finance, then run this code cell. The exclamation mark means that we are in the console and we are collecting and downloading Yahoo Finance. Great. Okay, once you get this message successfully installed, we can now use Yahoo Finance. We do have to import it, Y Finance like this, and then we'll be able to use its functions. For example, I'm going to use yfinance.download. So this is going to allow me to download some data. Inside of this download function, first we're going to pass in a tickers argument. This can be one or more stock tickers or stock symbols that you want to use. So I'm going to pass in here my stock symbol variable, which I'm going to create. We can choose any stock, for example, Tesla, which has the ticker or symbol TSLA. Make sure it's capitalized. Then we have a start argument. This is going to represent our start date, which is when we want to begin the data set. And in my case, I'm going to define start date. Let's start at 2016-01-01. All right. Then we're going to pass in another argument known as end. This is going to be the end date for our data set. End date, and we'll create another variable called end date. Just make sure that the end date has actually passed so far. It can't be in the future because we can't fetch data that hasn't existed yet. So I'm going to do 2021-01-01. This will give me a neat 5 years worth of data. Okay, great. The result of this is going to be a data set, and I can print out that variable and view what it contains. Okay, and look here. We can see we have 6 different columns. The date is our index column, so it doesn't count. It's just used to index each row. Beginning at 2016-01-04, because we only have the values for weekdays, and ending at 2020-12-31. So almost 5 years of data. We have open, which is the opening price of the stock on that day. High, which is the high price of the stock on that day. Low, which is the low price of the stock on that day. Close, which is the closing price of the stock on that day. Adjusted close, which is the adjusted closing price of the stock on that day. And the volume, which is the number of trades. Awesome. Okay, and just like that, we've been able to grab our data set. We can also call dataset.info here to get some information about the type. And you can see here the type is a pandas data frame. The pandas data frame type is very commonly used because it allows us to work with our tables much faster, and we're exposed to a lot more functions. Okay, coming up now, we can actually create more data, more columns here. So I'm going to create a new code cell. I'm going to grab my data set and I'm going to create a new column. This column is going to be increase or decrease. Then I'm going to use the NumPy library in order to set the values at this column. So I do have to import NumPy in order to use it. I'm going to use NumPy and I'm going to use where to set a condition, and I will fill that column depending on the condition. So I'm going to check where the data set at the volume dot shift of -1 is greater than the data set at the volume. So I'm checking where the data set at the previous row at the column volume was greater than the data set at the current volume. In that case, I'm going to populate that row with 1 at this new column. Otherwise, I'll populate it with 0. So if the previous day is greater than the current day, that means we had a drop. So this would actually be called decrease because 1 would be true, 0 would be false. We could do it the other way as well. We could have a less than here and we could set it to 1 for increase and 0 for decrease. Doesn't matter. The way we have it now is if the previous day is greater than the current day, we'll populate the column with 1 because we had a decrease. Otherwise, we'll populate it with 0. Then I can run this code cell and we'll see we now have a decrease column. We have a 1 if the volume decreased, and we have a 0 if the volume increased. Next, let's add some more columns. For example, we can determine if we should buy or sell the stock depending on if the price increases or decreases. So I'm going to make a new code cell. I'm going to grab the data set and I'm going to make a column buy or sell. Then I'm going to use NumPy again, and I'm going to find where the data set at one of the columns like add close typically is used. I'm going to check the row before it with shift -1. If that is greater than the data set at the present day add close, that means that the price decreased, which means that I should sell. So I can have here a 1 for sell and a -1 or a 0 for do not sell or buy because the price dropped. This is quite a rudimentary way of determining whether to buy or sell. It's a simple strategy, but it will work for this case. All right, so I can just call this, let's see, sell, because or buy, rather, because if price dropped, then we have 1 for buy, -1 for do not buy. So I can now paste the data set again, and we will see a new column called buy will have been created. If the price decreased, we have a -1 on that adjusted closing column. We can also do this on any column we want. We could determine whether we want to buy or sell on any of the columns. Doesn't really matter. Typically, adjusted closing price is used. All right, next up, let's add in another column. All right, so what else might we want to add to our data set? Well, we might want to calculate the return. What return are we getting on our investment? So I'm going to make a new code cell here. At dataset, I'm going to make a returns column. I'm going to grab the data set and I'm going to use the add close, adjusted closing column, and I'm going to call the %change function. All right, then I am going to paste out that data set variable again just to see what we now have. All right, so now we have this return for the first day. We don't have any returns, but then we can see the returns at each day. Because the first row is not a number, we want to drop this row. To drop a row from the data set, we're going to grab the data set and assign it to equal dataset.drop_NA. That is going to remove any null values or not a number values. As well, one final column that we can create a class column that tells us whether our return was positive or negative. So I'm going to make another code cell at the data set. I'm going to create here our class column. I'm going to use NumPy to set a condition. So where the data set at the returns column of the previous day with shift -1, if that was greater than the data set at the current returns column, then we want the class to be that the return has dropped. So we have a negative return. Otherwise, we have a positive return. Then I can paste the data set again and run the code cell. Now we will see here we have a class column, positive or negative. If returns was positive, then our class is positive. If our returns was negative, our class is negative. So this is a way of turning a numerical category or numerical feature like returns, which is on a scale, and turning it into a categorical feature of class, which is just a binary, positive or negative. Awesome. Okay, we could make more columns as well, but that is a great introduction. Coming up next, we are going to analyze the data set. I'm going to show you some handy properties and functions that we can use. So head on over to that next lecture. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to load in a data set about a stock. And in this lecture, I'm going to show you how we can analyze the data. All right, first up, we can generate a statistical summary of the data set just by calling dataset.describe. Then I can run that code cell, and here we'll see some stats about each column. As well, typically, you'll want to check if you have any null values or not a number values. For that, I'll call dataset.isNull, and I'm going to grab values.any. So here I'm checking if we have any null values. Okay, we get false, which is good, because if we had any null values, we would have to handle them. Typically, we remove them. All right, next up, there's a lot more we could do. We could get the columns, the data types, the shape. We can also group our data set by any column. For example, let's group it by a numerical column first, like add close. I'll call dataset and then I'll use group by and I'll pass in here the column name. Then I can grab size to get the size of that. Okay, so here we're taking each of the closing prices and grouping them. Now, because the closing prices are so unique, this has really no importance, but it's more important for a categorical value, like if we had, for example, a value of class. Okay, so for that, I'm going to take the class column and I'm going to put it to use. So I'm going to make a new code cell here. I'm going to grab data set and I'm going to group by the class and return the size of that. Okay, look at this. Now we have negative and positive. So we can see a categorical feature makes more sense for grouping. We have 626 instances of a negative class, meaning a negative return. That's what that column was. And 632 instances of a positive return. All right, we can also visualize the data by building different plots. For example, just as a sneak preview, I can use the Seaborn library in order to show the counts of a class, because although this is just a binary class, meaning it has only 2 categories, we could potentially have a categorical feature that has a lot more possibilities. So I'm going to first import the Seaborn library. It's a very popular library for visualization. Then I'm going to generate a count plot, which will plot the number of rows per category. I'm going to pass in an X as class, which is what I want to count, and my data is my data set. All right, then I can run this code cell, and look at this. We have this count plot that's been generated. On the Y, we have the count, about 630 for each class, and on the X, we have the 2 classes. Next up, let's go and move on to our next lecture, where we're going to learn how we can visualize data even further, because there are quite a few plots that we can create. So head on over to that next lecture. Hello everyone, and welcome back to our course. In this lecture, we are going to continue analyzing our data by building out more plots. All right, so next up, we are going to build out a box plot. So I'm going to create a new code cell here. I'm going to grab my data set and I'm going to create a box and whisker plot. I'm going to use the plot function. The kind is going to be a box, and that is going to create for me a box and whisker plot. Subplots we will set to true. The layout we can set 10 by 10. And that is going to be the number of different values that we have. Okay, I'll have share X be false and share Y be false as well. Then I will call pyplot.show to ensure that we are showing our data set. Now pyplot we have to import. At the top of this code cell, import matplotlib.pyplot as pyplot if you want to actually use the pyplot library, which you do. Okay, we'll run that code cell and just give it a moment to generate our results. Okay, that's quite small. Let me just make this a bit different of a layout. We'll do 3 by 3. Okay, there we go. So we can even do 2 by 2. That's going to be just the shape of our layout. You must have at least 3 by 3 though, because we have 9 different values to plot. So depends on the data set, but in our case we have 9 different plots, so that is what we will put here. That is a bit small, so we can add another argument here. That is our fig size, which is the size of our figure. We could do 3. All right, it has to be 3 by 3 though. We have to do width by height. All right, and okay, that's going to change the size here of our figure. I could do this 9 by 9 to make it even larger, just to make it easier to see. Okay, here we go. I'll make it even bigger. Let's do 20 by 20. I just want to make sure that we can actually read the box and whisker plot. Okay, here we go. So we can see we have our box and whisker plots. We can look at them all individually as well. We have our different different columns: open, high, low, close, adjusted close, volume, decrease, buy, and returns. So this box and whisker plot is going to show us the distribution of our values, and the box is going to show us the average distribution, and the dots, those are outliers. All right, next up, let's create another type of plot known as a histogram that will show us the frequency of values. So let's make another code cell. I'm going to grab my data set and use the plot function again. This time, however, I'm passing in my kind argument as hist, short for histogram. Subplots is true. The layout, I can do the same 3 by 3 as last time. Share x is equal to false and share y is equal to false. And then we have our fig size. We can do 20 by 20 again. All right, then I will call pyplot.show to ensure that we show the previous plot in this code cell. And here we go. Look at this. Now we can see each of the columns in a different chart, and we have the frequency of the different values. On the y is the frequency. So if you only have one range, then there's only one bar. But if you have several different ranges, for example, for volume, then you have several different bars, and we have the frequency of each range of the bar. You can also then see here, mostly the interesting one is the volume here, because that's the one that actually has different bars here. Because we can see that the range of 0 to 0.25 was most frequent. It appeared 530 times. The range of 0.25 to 0.5, that was the second highest in frequency, and so forth. We can also create a histogram really quickly with dataset.hist, just like that, then call pyplot.show. That's going to create a quick rendering of a histogram. Although we didn't really pass any size here or anything, so it's just the default that's created. You can see there actually is some variation with open, high, close, adjusted closing price. There actually is a little bit of variation. It's just hard to see. Okay, here I can pass in a fig size. I can do 20 by 20 for the hist function. That's just going to make it a bit easier to see. Okay, we have open, high, and low. And then we have on the y is the frequency, and on the x is the range. So for something like the closing price of the stock versus volume, they'll have a different x axis because they represent different values. Close is a value of the stock, and volume is here, it's in 1/8, which means it's the number times 10 to the power of 8. All right, so 1 with 8 zeros at the end. So volume is much larger than close. That's why we have different x axes. All right, next up, let's build out our classic line plot. So this will show us the distribution of our feet.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.